Hello everyone. Last time we did the same problem in C# 27, remove element, and today we are scripting it in JavaScript. This problem was given by Microsoft in a coding interview, so let's figure out a solution. I'm not going to go through reading the problem since it's quite big, and here they explain for the custom judge, this is how your code is going to be judged from the server. But I'm going to give you, for the people who haven't watched the C# video, and if you want the whole visual explanation over there with paint, then I would recommend you watching it. Anyway, we have an array with a couple of elements, so I'm just going to show you 1, 2, 2, and then I have 1. And for example, I have a value that's going to be 1. Actually, let's place it at 2. And the whole idea is that I want to return an array that's still going to be as sorted as before, so I'm not going to do anything to the sorting. I'm not allowed to take this one and place it here, for example, and this 2 here. I want to remove the 2's. So in the end, I should be returning an array that's going to be 1, 1. And of course, I need to return an integer showing how much of the elements I'm actually going to take into consideration. So for example, here, I'm going to have this. We can have quite a lot of gibberish here, doesn't matter. But I'm going to be returning 2, meaning look at the first 2 elements of the list, the first 2 elements of the array. So they are 1, 1. And that is going to be successful based on our custom judge. And that's pretty much it. Another example I'm going to give is, for example, if the array has 3, 2, 3, 2, 1, 1, and then I need to remove all 3's. So every integer that is actually 3 shouldn't be in the array. And I am going to have, you guessed it, 2, 2, 1, 1, and I will be returning the number 4, meaning look at the first 4 numbers of the array. They should be as sorted as before. So here they're not as sorted as before. They're not sorted at all. Actually, you can say that they're sorted in a decreasing order. And after that, I might have these 3's, but nobody is going to care because we're going to look at the first 4 elements. So that's pretty much it. Let's start and code it up. Now, the first thing that I usually do is do a very quick if statement for the control flow. Now, usually you don't need to do this. So I'm checking here if nums.length is actually equal to 0. And then I'm going to be returning 0 because obviously I'm not expected to do anything here. If by the constraints you see that, for example, num's length is always bigger or equal than 1, obviously there's no need to check. You can just go to the straightforward algorithm explanation and coding. You don't need to do this control flow. But since I know that num's length might be 0, then I just put this check over here. Most of my videos have this check, and sometimes I usually miss reading the constraints. Always keep them in mind. All right, so now I'm going to do the following thing. If I have the array and I'm going to get 1, 2, 2, 1, what I want is to have 2 pointers, and then each and every one is going to move. And if I don't have the occurrence of a value, then I am going to say that the first pointer is going to be equal to the second one, and then I'm going to move the first pointer, and of course the second pointer is the one that's going to be moving at all times. And if I play it out, here I can have first pointer that's going to be equal to 1 and second pointer that's going to be equal to 1 because both are going to be pointing at the start of the array. And obviously 1 is not equal to the value, so I'm going to say first pointer is going to be equal to second pointer, and then I'm just going to increment the first pointer. So now at the next run, when I have 1, 2, 2, 1, first pointer is going to be here at 2 and second pointer is going to be here at 2 as well. Now 2 is equal to the value. Then I'm just going to increment the second pointer. The second pointer is going to be here. This is as well 2 equal to the value. So I'm not going to do anything. Move the second pointer to 1. And here 1 is not equal to the value. So I can say first point is going to be equal to 1. Actually to second pointer, which is going to be equal to 1. And I'm going to increment first pointer plus plus. Meaning that first pointer was here, I'm just going to say that this is going to be a 1, and then I'm going to increment the first pointer pointing to this number 2. And since I don't care what I have beyond the array, I'm just going to return first pointer, meaning that I'm going to return 1, 1, 2, 1 as an array, and of course the number 2, meaning look at the first 2 numbers of the array. So that's pretty much it. That's a very simple solution. So let's code it up. The first thing that I want to do is creating a first pointer. So I'm going to say first point. It's going to be equal to 0 because I want them both to start at the same speed, so to say. Let's go with the second one. I'm going to create a for loop for this. So I'm going to say let second point is going to be equal to 0. Again, I want them to be equal, so I can just say first point here. Then I'm going to say second point less than numbers.length, if I can type that correctly, and second point is going to go forward. Okay. Now I did have to remove these comments here, but I wanted if the second point is not equal to the value, right? Because then I am going to increment the first pointer and I'm going to switch. So I'm going to say if second point, actually nums of second point, is not equal to value, so value, I can say then nums of first point plus plus is going to be equal to nums of second point. And actually, now I'm just going to remove these, and the solution is very, very similar, actually pretty much the same as in C#. And the last thing that I'm going to do is I'm going to return first point. All right, so you know this operator, it means that I'm just going to assign first point to second point, actually second point to first one, and then and only then after the operation is complete, I'm going to say plus plus over here. That's why this works. All right, and I think that's going to be it. Let me just double check to be sure. Nums length second point is going to go forward. Nums second point is not equal to value. Nums of the first point is going to be equal to nums of second point, and then we're going to increment first. Yeah, okay. Run code. And hopefully it passes. All right. Use example test cases, and then let's submit it to the server. All right. Good. And it passed. Actually, it passed very badly. But once again, don't look at these because these scores are not relevant at all. You can see that they're different almost every single time when I pass them. And if I go to details actually here, let's see the quickest one. And yeah, you can see that the quickest one is actually pretty much the same solution, but with I and J, right? Right, so don't look at these. All right, the final thing that we need to be talking about, space and time. So I'm just gonna write space time. The space, since we are, actually this is part of the description over here. You must do this by modifying the input array in place with constant extra memory. So this one is done. Since I'm not allocating anything for the array, I'm just doing it in time, in place. And I don't allocate anything, that's gonna be constant. And the time, well, this is the only loop that I have, so as big as the array, right? Which it means that it's gonna be a linear. All right, and that's pretty much it. So linear time complexity and constant space complexity. That's the solution. Thank you for watching, and if you have any questions, leave them down below. Bye, everyone.